In this short video, we're going to evaluate a log expression without a calculator. We'll do one easy example and one that's a bit trickier. And then I'm going to show you a real easy method for graphing log functions. In this first example, we're going to evaluate base 4 log of 64 without a calculator. The first thing you do here is let that log equal x. And then once you do that, you can rewrite this in exponential form. And the exponential form is 4 to the x equals 64. Well, that's an easy one to figure out because 64 happens to be a power of 4. 4 cubed is 64, so that means x equals 3. Now let's look at a second example. We want to evaluate the base 8 log of 32 without a calculator. And we start by rewriting and letting x equal that log like we did with the first example. And also, we then rewrite it in exponential form. In this case, we get 8 to the x power equal 32. Now this seems puzzling because it doesn't seem like there is any power of 8 that's 32, but in fact there is, a fractional power. To find that fraction, we have to rewrite both sides as the same base raised to a power. In this case, 8 is a power of 2, so we can replace 8 with 2 cubed. 32 is a power of 2. We can replace 32 with 2 to the 5th. And now we can apply the exponent rule on the left. A power to a power means we multiply exponents. We then get 2 to the 3x equals 2 to the 5th. Now what this implies is that 3x has to equal 5 since we have the same base on both sides. So then we let 3x equal 5, and when we solve that, we get x equal 5/3. And we can even check this result. Using the exponential form, we let x equal 5/3. 8 to the 5/3 is the cube root of 8, then to the 5th power, which means we have 2 to the 5th, and that equals 32. So it all checks out. And now we're going to look at graphing a log function. Here we have f of x equal the base 3 log of x. The first thing we do is take the f of x out and put y in its place. And then we wonder how we're going to get points because we don't have a base 3 log key. Well, the trick here is to just rewrite it in exponential form. So we do that. We write it as 3 to the y equal x, and we get our points by picking the y values first. When we let y equal 0, x is 3 to the 0, which is 1. So we have the point 1, 0 graphed right here. When y is 1, x is 3 to the 1, which is 3, giving us the point 3, 1 right here. When y is negative 1, we get x equals 3 to the negative 1, which is 1 over 3 to the 1, or 1/3. And that's this point down here. And then finally, when y is 2, x is 3 squared, or 9, giving us this point out here. And then we just connect up these points. And I've done just that here, connecting up the points with these blue line segments. And then I wonder, how far to the left does that graph go? Is there any value of y that will give me x equals 0? In other words, does 3 to some power equal 0? It turns out there's no power of 3 that will give you 0. So what happens is the y-axis serves as a vertical asymptote, or the line x equals 0. The graph continues down to negative infinity and never reaches that y-axis. And you can see it's an L-shaped graph, just like an exponential function, except it's turned sideways.